Forgot to do the Discord notification real quick. Cast. All right. Let's go. So what am I doing today? We're working on the cast programming language. Hello, Pigorli. How are you doing, Pigorli? Hello, Ogma. Oh, I'm just starting here. All right. Do you even do programming, Ogma? Or um or something similar? No? Alright. You're just here for the for Pigorli, I'm assuming, right? I always go to every single Twitch channel where if I see Pigorli there, then I'm probably there too. I don't know. I'm just following Pigorli around Twitch. But it's really easy to do because Pigorli is everywhere. Right? Hello, Nigel. Hello, Penguin. Alright. Okay. We're working on the programming language.
Hello, Nerdsel.
Hello, Nerdsel. You're interested in knowing about programming and you like listening to the background? Alright. Okay. So you like hearing me rage about whatever I'm using. I'm hating everything that I use all the time, right? Yeah, that's how programming goes. You just try to do things, and then the tools, they are trying to prevent you from doing the work. They are like bad on purpose or something. Classic programming. All right, so the mod issue got fixed within 4 hours. Yeah. Yeah, we have the issue fixed in the language server. There was the race condition in the library that I'm using, and I opened the issue there, right? I opened the issue there, and they closed the issue because they fixed it, right? That was a quick response. I did not expect a quick response because from what I've seen, Camel, everything moves really slowly. I did something similar to my fix, but just oh yeah, you can like write without protection if you want, I guess. Oh wait, mutex use RW protect is false. What does this even mean? That's a little bit of a different thing. Oh, because there's a write bytes too? Yeah, okay. All right. Anyway, so this means that I can just upgrade the thing, and then it's going to work instead of using my hacky fix. Right. Let's start with that. My hacky fix is just over here, and then I just remove that. But then I just update the thing. Wait. Does it mean that they actually pushed it to the OPAM, the package registry, then, right? Linol 010. They didn't push it to the to this thing, no. Because I'm pretty sure that's the old version. Yeah. And this is going to be in 011. You know what? I'm just going to like keep my thing here, and then I'll just say to do remove once linol 011 is released. Okay. Okay, but what we're actually doing today, right? Let's open the examples and the lists, right? We're still trying to make the lists work. There you go. And as you can see right now, this is failing the type check. It says add t is not equal to int 32. And then when I'm hovering this also says print t here, which is completely wrong. So I have some type variables that are leaking outside of their generic functions. And remember this thing about the scope escaping? I think this is kind of like related. And I think I know how to fix the scope escaping thing. And maybe I will figure out how to fix this one too here. Hello, Dev Ninja. So here's this bug, right? That we currently have. Although this bug doesn't really matter because it only like it's thinking that incorrect code is correct, right? But the bug is over here, right? So we have a generic function that calls into a regular function, and we want the type of the regular function to be inferred. This over here just says t into t, by the way. But because it's the same time, it thinks it's recursive. Maybe, you know what? I should only say that the type is recursive if it actually like contains itself within itself, right? But that's not what's happening here. Hopefully today is the day the first Rick begins. Many will follow. No, I don't think so. I'm not even sure that I can fix this bug today. Before going more into this bug, I want to fix this a little bit. So yeah, because I want this to just print t into t, right? This is a little bit of like weird thing. So I'm just going to fix the printing of the types. Let's do that. Fix print. I know, improve, I guess. It's not really a fix, it's not a bug. Improve printing of types. Okay. So I introduced this thing where we, like, if the type is recursive, then it's going to be prefixed with the ID so that we can see that this and this is the same type, so which is basically means that this is T and T, right? T into T, but this is like just noise here. So I only want this to be for true recursive types, right? which contains itself or within itself, not outside of itself, right? Yeah. So I kind of did this thing already when I'm doing the substitution. When I'm doing the substitution of the bindings here, and I'm doing the variable, I'm counting the substitutions inside. No, maybe that's not exactly the same thing. Let's just go to printing directly and see what can I do here. So I'm trying to print a type, right? And I'm trying to print a type, right? So here's what's happening, right? I'm trying to print a type, and then if it's recursive, if I am visiting it for the first time, then I'm printing the type. Otherwise, I'm just printing recursive. That's what's happening, right? So like, even the type is not recursive, but it's appearing twice in the other type, then it's going to print as recursive. And that's what I don't want to do, right? So but you distract yourself by making a ppx if let. Isn't there an existing if let? If let some x be x, then this. Like, it's not even formatting, so it should like, it should still be parsed as proper, because like, you cannot just do custom syntax, you know, camel, right? So how would it even look like with a thing? I'm not even sure. If flat, I don't like, this is still incorrect syntax though. It's you still need to have correct syntax, unless it's like add if let or like whatever, like this if let or something. I'm not sure. I feel like there probably is a solution, but it's probably ugly, so it's not an improvement over a manual match anyway. Yeah, I think. Anyway. So how do I print the things, right? When I see the type the first time, I still want to print it if it is recursive. How do I know if it is recursive? Well, previously, I was actually printing the type twice and saving the results of the recurse stuff into a separate cache, and then I look up in the first cache if it was actually visited more than once, then I do that. You know, then I print the ID here. But it's basically like the recurse cache should yeah, I'm having the visited count here, right? So I know how many times I have visited it. But the thing is, I need to like enter the type and then exit the type here when printing it. Do I try to rewrite this from like Scratch kind of? Like over, like I can see if I am currently printing the type already. That would mean that it is recursive, right? Yes. Yes. Oh, easy recursive. Okay, hold on. I think I know exactly what to do then, right? Okay, let's do this. Here's what I'm going to do. I think the recurse cache should, I should be able to like, not to just visit. I should be able to enter the type, to enter the thing, and then I should be able to exit the variable. So we enter and then we exit the variable with ID. Entered. So we will have a separate hash table which just contains like a boolean, or basically just unit. Am I currently in it or not? Or actually, like, how deep am I in it, I guess? Because, yeah. How deep, yeah, okay. So, like this. It makes sense. How deep are we in? How deep is your love? Yeah. Entered is hash table create 0. Visited. Cache. Cache dot visited. Cache. Cache dot visited. Enter. Cache dot visited. So we get the current visit count. I get the current visit count, and I increase the visit count. Visit count. Actually, instead of comment, let's just name this variable something else. Let's name this depth. Like the recurse depth, I guess. So when I enter a variable, I'm going to, in addition to and this enter says that it's entered it for the first time, which is also not what I want. I feel like I'm going to return unit here. Okay, but yeah, I need to basically increase the depth, right? Yeah. So we also need let depth of ID in cache is hash table find opt cache depth of ID option value with default being 0, right? So we do that, and then I say that let the current depth is cache depth of ID, and then I say hash table add cache depth ID is going to be current depth plus 1, right? That's what we do. And then when I exit the variable, I just say that I just say that the depth is depth -1, and that's all that I need, right? I think so. Actually, let's do that inside VS Code. So, as far as I know, usually when people make apps, for example, they don't over-optimize everything, so the code is kind of readable, right? What about programming languages? Are there going to be complex optimizations? I guess. I mean, yeah, but I mean, like right now, I'm not worrying about performance, so I'm just trying to write the code. So yeah, I am not really worrying about optimizations at all currently. If you want your language to be fast, then yes, for sure. But a lot of the optimization things are already like extracted into their own like separate projects. When you're like writing a language and you want it to be compiled to native code, then you can use like existing backends like LLVM and stuff, right? But then also there are optimizations that you can do to make the language, the compiler itself faster, right? I'm not sure how many language developers are actually doing some dirty tricks to make their compiler faster. Because compiler is like already difficult, and increasing the difficulty by introducing some like magic tricks to improve performance. Sure, that's a good idea. So like, yeah. Okay, I just want to run the LSP support here. I renamed a thing, but the OCaml language server renames some random things that have nothing to do with what I did. I hate it. It just renames things that should not be renamed. And also over here, I want to have a like a more general thing. In order to print the type, we just print a variable var using a print type shape. So this over here is the generic thing, because later we are going to have a like not only types are going to be inferred, but other things too. So over here we say that print variable is a function that takes, it's the generic function that if we know how to print, A, then we know how to print the inference variable. This is going to be function. If we know print shape function, then we have fmt and we have variable. Then we're going to do this, where we get the recurse ID of the variable and stuff and stuff and stuff. This is not print type shape. This is just print shape. And now over here, how do we write this, right? So once again, I am like, it is only recursive if I'm currently if I had currently entered this thing already, right? So I say that if recurse cache get, that's my cache, right? Cache is this recurse cache. So if cache depth of my current variable is more than 0, then it is recursive. Otherwise, it's not recursive. So over here we print recursive. That's the easy part, right? Otherwise, I'm going to enter the thing. So cache recurse cache enter ID, which technically means that the depth is going to be at most 1, but like this is a more generic thing, I guess. So we just enter this. So after 2-3 days after making such an optimization, you're gonna look at it and say, what the fuck, but wow, how fast that is. Kick W, in a year, you're gonna make TED Talk how you made the fastest language on the market. Yeah, maybe, I don't know. I don't know how other people make programming languages. I don't really look things up. Of how things are done usually. Just doing my own thing here, you know. Hello, Bad Cop. What if we make a new language that makes it easier to make new languages? Yes, that's what I'm doing. I'm not making like my final language yet, kind of. I'm making a small subset of it for now, I guess, which I will use to write the actual language. Okay, so over here I enter the thing and then I'm going to exit this thing. Exit this thing. And in the middle, we need to print the thing, right? Okay. So the only problem is that how do I figure out if I want to print its ID? That's the only question. Right? Because in order to know, like when I'm printing recursive, what is the thing that is recursive, right? I want to give it like a name. And instead of a name, I'm giving them IDs, right? So I want to know if it is recursive. But in order to know if it is recursive, all that I need to do is is it recursive? We're going to have another cache. Is recursive is effect. Why is it even an effect? Wait, why is it even an effect? That makes no sense, right? I think is recursive is just a new recurse cache. And that's it. So just going to use it here. And with cache is not going to do that. Right? With cache here. With cache. Print var. Let me fix this first. So I'm going to say that if is recursive cache is visited ID, then I'm going to print the ID here. Like that. Right? But how do we figure out if it's visited? I'm going to, over here, since this is a recursive, I'm going to say that is recursive, recurse cache, visit, or I mean, just enter, I guess, it doesn't matter. I don't care about the depths here, so just enter the ID here. Like so. Hello, Bad Cop stream when? September 2nd, 2028. I don't think Cast wants to be very fast, seems it has other goals. Well, I mean, technically I want Cast to be very fast, right? It's just, it's not my priority right now. But eventually, I want the language to be something like Rust, right? Where we have both high-level abstractions and we have access to the low-level stuff at the same time. But for now, I'm just focusing on the high-level part of the language, not on the low-level part, because that's more important to me. Because that's what allows you to write code easier, right? But does Cast want that? Did you ask it? Of course, who doesn't want to be fast? Recursive cache enter. I think that's all, right? And then over here, when I'm doing with cache, what am I going to do? Recurse cache with cache. So just doing that, and then we are continuing it. With cache, recurse cache create. Yeah, this is like the new cache. Okay. So I just do this, literally. We do recurse cache with cache, recurse cache create. We're going to do that twice. I'm going to do this thing twice. Why am I doing this thing twice? Well, that's because first we're printing to the no-op formatter, and the reason we're doing this is we print to dev null basically, and while doing that we are determining which types are recursive and which are not. And then the second time, now we know which types are recursive. That's now we can use this information to actually print the thing, right? But after I'm doing that, I also want to like clear the recursive cache, I guess. Recurse cache. I guess like I can just create a new one. Yeah, sure. Same as clearing. Wait, that's not what I want. I guess colon equal. Let's do the clear then. Recurse cache clear. Let clear cache is hash table clear visit count and depth. Visit count hash table clear depth. Like that. JavaScript, that sure does not want to be fast. What? But why is there so much work that is being put into it being fast then? They could have never improved its speed then, right? But it has come a long way since it was first written in 10 days by some guy. It was a lot slower back in the days. So why is it faster then if it doesn't want to be fast? Because being faster is always a good thing. Right? It just doesn't want to sacrifice the speed for the other things, right? But if we can get the speed without changing the language, then sure. But I mean, I guess like that's a little bit of the different things, right? Like yeah. But like I'm just saying that I want to, like, I believe that it's possible to make a language that has both, right? You don't have to choose between speed and expressivity of a language. Yeah. But there is still like this trade-off, right? Like, because we're still going to have something similar to Rust borrow checker, and that is something that is turning a lot of people off, right? But what I want to do is to make it to be easy to like have to like write code with a garbage collector, which should be like optional, an opt-in thing, I think. But you shouldn't switch the language to. You should need to switch the language to like do these things, you know. Turning people off is good actually. If your language has mass appeal, it will be mid. Right. Yeah. Anyway, we'll see. But it can actually happen. Like if this project actually gets somewhere, you know. Like before I introduce the borrow checker, the people can like the language, and then once I start introducing the borrow checker, people will stop using the language. You know, they will fork it and keep the original one without. The original Rust also had the garbage collection, right? It's okay, people don't like functional stuff anyway. Yeah, but like I'm also not... I'm not advertising it as functional, really, right? You should have kept the words algebraic effect systems. Yeah, put the monad as the first word when explaining what the language is about, right? Yeah, sure. Recurse cache. Yeah, so this is the substitute variable. I guess I'm just going to enter this thing. So enter should then return boolean after all if it is entered for the first time or not. No, that's not what it should be doing. No, unit. But I will need to like rewrite this code then, I guess, because I need to enter and exit now, which is a little bit annoying, but in this case I don't like care about that, I guess. Or maybe we have some other API which like takes a function, you know? So like we have enter and exit. This is like imperative, right? So I need to like not forget to do the exit. But then we do the function visit, then it takes ID and it takes like function f, which is a function from like a function that we're going to do while visiting, right? And then we do cache. And that's going to be basically enter ID. And then exit ID. And then in the middle, I'm just calling function f. Right? But then I want to know if it was not visited, basically, right? So this should then return boolean, whether it was or not. Wait, no. Nah, that's weird. I guess I just do this. If I just do this. Cache is recurse cache get, and then I say that if cache recurse cache visit count ID is equal to 0, then I'm visiting for the first time, right? Otherwise, I have visited it before. So yeah, over here I'm saying cache recurse cache enter ID, and in the end I'm going to exit. I mean, technically I only need to enter here. I don't even need to exit because I'm not calculating whether I'm currently in or not, so it doesn't really matter. But I will exit anyway because I am nice. Okay. Okay. So it's a success now. The thing has built successfully, but OCaml is showing me fake errors. So let's restart OCaml language server. Thank you. Okay, and then we restart cast language server, and then I go to here, and let's see what it's going to say. So now this just say t into t, right? Because this is not a recursive type. This is the simple way to print it, right? F is t into t, and then over here we have actually recursive types, and in this case the type is being printed like this. So this is the recursive type, the list, which contains itself. In this case, we'll print ID and we'll print recursive. Okay, nice. This is better than before. This is better than before. Let's commit. Improve printing. Let's remove recur, like only print recursive. It's truly recursive. Okay, that's it. Lots of people on my TL. What's TL? Arguing about this thread. Go versus Rust, blah blah blah, who cares? Yet not a single one of you ever implemented the house builder correctly. Is that why you are not streaming? You were writing the house builder? Hello, Veldek. Goodbye, Veldek. This was a year ago. Wait, where's the date of this post? This is the date of the other post. This one is still a year ago. Okay. Right. Okay, so now we're back to this thing, right? So here's the bug, right? We have a function x into x. What's the type of this function? What's the type of this function, right? Like when you just look at this on its own, the type is not inferred, right? It's like some type into some type, right? We don't know what the type actually is. But then, if we try to call this function from some other place, for example, if over here we try to call this function with a string, this tells the inference algorithm that the type of function f is string into string, right? And then similarly, if I try to call this function from inside of a generic function, because inside of this generic function, the type of x is t, so I'm trying to call function f with a variable of type t, this infers the type of f to be the function that takes t and returns t, right? But that is not correct. Hello, Okina. So why is this not correct? That's not correct because f cannot be typed t into t because t doesn't even exist in this scope. In this case, using the inference, our type variable escaped the scope. And that's called a scope escape, right? Literally. I'm kind of seeing Dev Ninja point why this is so wrong. What? Wasn't Dev Ninja saying that it is actually not wrong? Did Dev Ninja do a new point today? What's wrong? What's wrong is that f cannot be typed t into t. What's t? What's t here? T doesn't exist here. T only exists inside of the generic function, right? Anything. No, it's not anything. It's something that was passed as an argument, but nothing is passed as an argument to the generic yet. Imply generic? No. So should I be able to call this function with like what can I call this function with? Right? Can I call this function with nothing? Because nothing is of type t, right? Because the only thing of type t can be created inside of this function. Um, um, isn't t a variable? It is a variable. But the variable has a value when we instantiate the generic function, right? No. We were looking this up before. This is a bug. This is a bug. This is not been compiled in a proper language. It's not a unique type declared in the function. Yeah. Something. When call define a generic function using f is inferred as t of the generic function. Yes. That is it. And that is wrong. So this is called scope escape. We were looking at this the other day. Scope escape, right? It's counterexamples.org here. When we have both polymorphism and type inference, then there's an issue called scope escape, right? This was an issue in every single language. What happens to type of f when generic gets instantiated? Well, so like, nothing should happen, right? Nothing should happen to f when generic is instantiated. Because the types of function, like, because every value should only have a single type, right? Like, it should not change its type while we are inside of the generic, right? That should never happen. Yeah. So that's like the thing, right? But So what I'm saying basically, here's how I feel like it should be fixed. Basically, we should be able to always write a type annotation, right? We should always be able to write down the type. So over here, I cannot write the fact that this is t into t, because t is not found in the scope, right? So I cannot explicitly say what's the type of this function here, right? And because I cannot, it should not be possible to do that, basically, right? Kind of. It would be really nice if we want to do that. So because we want this to be able to be written, what does that mean? So we want to be able to write the type of this function over here. So in this case, function is t into t, right? In this case, it can be written because t exists in this scope, but t does not exist in this scope, right? F should also be generic. Well, I mean, if f is generic, then it's a different thing. Yeah, we can make a generic, right? F, it can also be a generic, like u, and then x of type u into x. We can do that. I don't want to do the automatic inference that this is generic. I want the generics to be explicit, I think. But this would work. So over here, we would call the function f by that, and that means that f is u into u, and then f, when it's instantiated, now it becomes t into t, because now we replace u with t, basically, right? When doing this. You're still thinking in Haskell? Yeah, because in Haskell, this thing is called let polymorphism, which automatically infers this thing to be generic. But it doesn't, I don't want it to, I don't want let polymorphism. I'm pretty sure. I saw an article somewhere when they say that let polymorphism is bad. It complicates things too much without any benefit. So yeah, we want, we just want the type here to be able to explicitly be written, right? So what should happen is that I should be able to write the type here, and I should be able to write the type here in these two places, right? So what can be written in both of these places, right? What can be written in both of these places? So we have the type that should be written in one scope, and we have the type that should be written in the other scope. So what are, like, basically, what are the variables that we can use in both of these scopes? Well, it's very easy. The answer is the only thing that is visible from both scopes, and the only thing that's visible from both scopes is their common parent scope, right? The lowest common ancestor thing, right? So we have like the type written in one place, and we have the type written in the other place. These places, these are scopes, right? Scopes, they have parents, right? Because we're nesting scopes. But then somewhere we have the root scope, right? So eventually we see that stuff, right? But what we want is we want to find the most general one that the lowest common parent, and everything that is visible in this scope can be written in both child scopes, right? Does that make sense? That's very easy, right? I think that's easy. So what this means basically is that I feel like the inference algorithm, when the variable is not inferred, we should still keep track of which scope it belongs to, right? And I don't need all the scopes. The only scope that we care about is the basically the lowest common ancestor of all the scopes where this variable is present, right? Yeah, that makes sense, right? Yeah. So when we say that a variable that is over here is equal to variable that's over there, then we also calculate their common parent, and then we see that all the bindings, all the variables that we use to write this type are actually existing in the scope. 3 people standing on rocks. I don't know. To me, this seems actually like a single person. You know, this is the head, and this is the boots. You know, this is the knees, and this is the body, and here's the hands. All right, fine. But yeah, that's my current idea of how would I go fixing this bug, right? But like technically we don't need to fix this bug right now, but I think it's very similar to the problem that I'm actually currently having. So over here it says type check failed, print t is not equal to int32. So why do we have this bug, right? Why do we think that the type of A is a list that contains print t? Why is that? Well, print t comes from over here, actually. Right? What if I never print? Then the type is going to be... Wait, is the type still print t? Wait, hold on, that makes no sense now. Can you show an example? An example of what? This is literally the example. Right, over here. The example is that, in this case, I'm going to try to unify the type variable over here and the type variable that's over here, right? What's the final type of f now? Well, this is going to lead to type error because we know that the common scope is basically this one, right? Because yeah, the result here is the type error. The compiler should say that there's an error here, right? Because t escapes its scope. That's literally what's happening here, right? So I'm going to try to unify this and that. The common parent scope is the scope where this one is defined, right? Because this one is later, right? We don't, yeah, like let is basically introducing a new scope in the next, like after the semicolon kind of thing, with this one being the parent. So this is the common scope, right? And in this scope, the variable t doesn't exist. So when we try to like say that this over here is t, because I'm trying to call function f with x, then t does not exist in the scope of this inference variable, basically, right? And we return an error. Yeah. So if you missed this part previously, Nerdcell, I can show you also this thing. Is it in temp? Something Idris? So here we go. We have test Idris, right? Literally the same example. Idris is the language with the dependent types, right? It is working very similarly to my language, where it doesn't have let polymorphism, right? So when we say fx is x, it is not inferred to be a polymorphic function. It is just inferred to be a function that takes some concrete type, but we don't know the type yet, right? And then we figure out what the type is by calling this function from a generic function, right? Generic functions are just functions taking type to an argument, right? So this is literally the same example, but in Idris. And if we try to do Idris, test Idris, right? Then it's going to say that while processing right and left side of G cannot solve constraints between question mark, no locals in scope, and T, right? It's basically saying that in this scope, we have the T, right? In this scope, the T exists in the scope, but in this scope, when we define the function f, T doesn't exist in scope. So that's how they say the same error. Yeah, it's a little bit weird. I think what I would write here is that T escapes the scope. Like, it's literally very similar to when in Rust you have a lifetime that escapes the scope. It's like the same thing, kind of, I think. It's like a borrow checker, but on the type variables. Tool alle ateralis. Hello, hello. Bro, didn't even activate Linux. Yeah, I'm broke. Cannot afford it. Okay, so yeah. All right. Yes. And then once again, let's go back to this example. F cannot have the type T because the type T does not exist as definition of F at the scope of the definition. Yeah, I guess maybe this is more a human error. Yeah. But yeah. Yeah, I guess. Okay, so what's happening here? Print T. Yeah, hold on, this doesn't make sense. Am I using print T somewhere? Print T only exists in this place. Okay, wait, hold on. What if I say this? If I have function f, which takes array or like list of underscore returns unit. Okay, that's what I want. This is list T, right? Let's comment the other stuff just in case. List type doesn't have fields. Wait, what? Going to parentheses here. Type doesn't have fields. Wait, is it in the prelude maybe? Collections list. Wait, what? This makes no sense. Hold on. Do I have more bugs than I thought I have? Cast run examples lists. Trying to instantiate a generic that's already in progress of instantiation. Add std collections list. Holy, I have a bug. So I guess the type doesn't have fields, but like, why does it show me this thing? Cast stop on first error. False. Trying to instantiate a generic that's already in progress of instantiation, sure, but then we have this thing, expected type got error. Oh yeah, because I instantiated it and it's error. Okay, hold on. I cannot say that the type is list T. But this thing doesn't exist. Do I need to like restart cast language server? Yeah, wait, hold on. Yeah, I need to restart it for some reason, which is weird. Also, might actually be another bug. Okay, there we go. So what's the type of A here? The type of A here right now is that it's empty, head is underscore, which is, I guess, int32, right? If I type that, and then the tail is error. Okay, maybe I should fix this bug too. Why is this happening? I'm trying to instantiate generic. It's already in progress of instantiating. We have another recursive thing. That is a problem. Fixing bug. I'm not sure what the bug is yet. Trying to instantiate generic that's already in the progress of instantiation. So what's happening? I'm curious if you've tried the Mojo language. Yes, I tried it, but very, very briefly. Like, I did a hello world there. And hello world was compiling for 10 seconds or something like that. And that was the reason why I stopped. Because I already was very unhappy with my Rust compilation times, which is why I moved to OCaml. But yeah, I mean, maybe that's just like some basic price for the hello world, and it doesn't really grow as your project gets bigger. But they do have a lot of interesting features in Mojo language, yeah. They have dependent types, as far as I heard. Among other things. Although you say that it's an improved Rust. So I think they, like last time we were reading about it, they could not do explicit lifetime annotations. It was still in the plans. So like, it's not better than Rust yet, as far as I understand, but it probably will be, yeah. But at this point, it's not ready at all, right? Yeah, it's not like they also promised to open source it, but it's not open sourced yet. They still did not open source it, right? Why is this website a light color scheme? I'm glad people are forgetting about Jai. Why? Is Jai bad or something? Also, they are marketing it as something for AI, and a lot of people are being turned away by that. GitHub. Modular Mojo. Wait, did they open source it? That's just the documentation that's open sourced? Or is it actually the thing? This directory includes the Mojo standard library, proposals, and documentation. Okay. But not the language itself. Okay. Anyway. How they will open source their compile implementation, but the language standard will of course be open, as usually all are. Well, why do you doubt it? Like, they promised that would open source it, as far as I understand. As far as I remember, they explicitly said that they were going to. Whole selling point is that it compiles with GPU, so no more CUDA. But there are already alternatives to CUDA, right? I think. I don't know really. I don't do that. But is it like the WGPU for Rust kind of does the same thing? But I guess it's not like a real language there, right? I mean, there's like Rust GPU also thing, which compiles Rust directly to GPU. But I don't know what's the state of those things. Like, I mean, maybe at this point there is not a lot of languages, but I feel like I don't understand why there is not a lot of languages that can target the GPU in addition to CPU, actually. That's one of the things that I want to do for myself too, right? I want this language to be able to target the GPU, or at least I want to write the shaders for my games in the same language as in which I'm writing the logic for the thing, right? So that I, like, yeah, I was going to target the GPU myself too. All right, anyway. Just run this. Okay, let's see. So we have a recursive type here, right? The list is a recursive type, which contains itself, right? The way we're doing this is this is just an expression that creates the type. And this over here is the generic. And generic is basically like a function. So this is like a function that returns a type, basically, right? So in order to figure out what the list with some like argument is, we evaluate this just like if this was a normal function. There is no difference here. So then while evaluating this function, we want to evaluate itself again, right? But there's the difference between the functions and generics, where generics are supposed to be called like if you call them with the same argument, then you get the same result, basically, which is why we are trying, like, we don't want this to be like a recursive function, right? Because that's not what we want. Instead, we want to instead we want over here use the already computed result, but we don't have the already computed result because we are right now computing this thing, you know? That's what's happening. Okay. Yeah. So what I need to do is actually pretty simple. When we have instantiation of generics, here's what we have, right? So yeah, the current state of the generic with the specific argument is that it's either not instantiated at all, or is it currently in progress, or it's already instantiated, right? If it's not instantiated yet at all, then we start instantiating it. If it's already instantiated, then we just use the existing result, right? But if it's in progress, then right now I'm returning an error. But what should happen instead in this case, because it's a type, and the types can be like computed later, kind of, this should return and what should this return? I feel like we should, when we start instantiating this, say that it's not in progress, but it's actually already instantiated. We should not even have this state. but we should instantiate it to the new not inferred variable, which is this type. And then once we actually evaluate this type, then we assign that not inferred variable to be this. And that will let me use this type in itself, right? Yeah. Actually, why was this working before, and why did I not have this problem before? Weird a little bit. But okay. Fixing recursive generic types, I guess. There are other... Yeah. Like, eventually we will have not only inferable types, but we will have inferable values too. I don't have this right now, though. But generics, they are like general. It's not like specifically a generic type here. It's generic something. And we just, for us, just types are values. But in order to do what I want, I kind of need the values to be inferable. So do I do this right now? While I'm looking at this code? So I just save the state to be not in progress here, but basically I want to save the progress to be instantiated immediately to the variable, where variable is a new not inferred variable in this span or something. Span, yeah, I have the span here, like this. And then instead of saving to the state to be instantiated result, I just say that this result that I have calculated, that's the value here. Yeah. But I cannot do that because, like, without specializing to types, you know? But we don't, like, we already have, like, generic functions too. It's not only types that can be generic. I don't know, let's try. Like, eventually I will have to do it anyway, right? So I guess before fixing recursive types, we need generic, like value inference. In addition, like basically more general than just types, I guess. Something is what I want. So this will allow me to have like things like const generics and stuff. So that's kind of easy to get started with, but then we are probably going to hit some things. I don't know. Right now we have let's see. So we have a type. What is a type? A type is the inference variable which can be inferred to the inferred type, right? This is what the type can be. And it can also be not inferred, basically, right? But if we compare that to what a value is, then the value is always inferred, and we want to change that. We want the values to also be potentially not inferred, right? So this is going to be inference variable e, like this. Okay. And now everything is going to break, right? Discard that. Discard that. You're using inference var for type, not inference for t. Yeah, the reason I changed it is because of the derive. I am using the derivers now, right? And they like if you do inference.var, which is just an alias, then there should be inference.equal var function, right? But so like I need to like re-export not only the type but also the equals function, you know. So yeah, maybe I will just stop re-exporting and just use the .t everywhere. Damn. This error doesn't exist, stupid camel. I need like no wait, what? It exists? Wait, what? Isn't it saying that it doesn't exist? Oh wait, it does. Wait, what? What does this? What does the error even say? The value underscore underscore 0 as type value shape bool. But expression was square of type a inference var. What? What's the problem here? Oh, oh wait, no, I am using inference var here, and over here, var t. Is that? Wait, no, there's no way that's the reason. That's not the reason. Wait, it is the reason? Wait, what? Huh? Wait, what's the difference? Because var is literally just the same as var t. Oh, I know why. It's because equal var. Yeah, okay. Actually, yeah, that's what I need to do because this is like a generic thing. So the deriver thinks that the equals and compare functions are also generic, but I'm actually not doing that. Yeah. But maybe I should. We'll see. Because something is going to break, I imagine. All right, let's see. So when am I printing the value? This is going to print the variable, and this needs to be print variable using print value fmt var, right? Okay, that's easy. Now in the types, what's the type of value? Now here's the thing, right? If the value itself is not inferred yet, then what's the type of the value? And for that reason, the value is not going to have the value here, but we also will have we'll store the type next to the value, right? This is going to be just type, right? So I just store the type next to the values. Sure. So over here, when we want to know the type of a value, it's now a lot easier. Because now we just do type of here. If we have the type, I guess I ignore the shape here and I just return the type, right? And we'll have a function type of shape, which is a value shape into type, and that's going to be a function shape into this. No, this variable. Okay. Okay. Now, when we do this, expect unit. So I know that the value should be a unit, but the shape is not inferred yet, right? But this means that I need to wait for the value shape to be inferred, right? So I do value var inference var. I feel like I need to like check all of the things when I'm expecting, and I'm not sure if I can await everywhere. Like this shouldn't say await. It should be obvious that it can be async then, right? Or does it not matter? Inference var await inferred. Maybe I just do that. In all of my expects. Okay. Interpreter scope. So now I need to be able to create the values which are already inferred, right? I will do this all the time. So similar to the type, I want a new not inferred, and I want the inferred things in value over here, right? I need to create the new not inferred value. New not inferred will have the type, which is also not inferred, right? So we don't know anything about this value, neither the type nor the value. Right? And then if we want an inferred value which has the known shape, then we will have the variable new inferred using the shape, and the type of this is going to be type new type inferred span type of shape, right? Type of shape. Which should be over here. Let's start with the shape here, and then this is then going to be a shape dot type of. Shape type of shape. This expression has type, and it should was a bit of type shape. Yes, we don't need it to be inferred, we just did that, right? Okay. So now when I'm saying that I'm adding a local, when I'm injecting the binding, I just need to say that this is a value binding, which is value inferred. Binding n. Okay. Substitute bindings. Substitute. So this is going to be substitute variable. Similar to substitute the type. This is going to be substitute variable, where substitute shape is substitute value shape. A new not inferred is going to be a value, new not inferred. Get variable is going to be value of type value. We just give it the value variable. And then we infer the value. Okay. Nice. And now when I substitute the value shape, if I have the shape. So now shaped is going to be not this, but it's going to be similar for the type. Similar to the type. This is going to, we have a new fake span here for now. So we just do value inferred span shape. That's it. Okay. Next. When I have the interpreter comment. So now this is what? This is pattern matching, right? So what happens when I'm doing the pattern matching? A tuple against a value. Well, in this case, since I'm doing the pattern matching, the value should already be inferred, right? So we just do value value var inference var await inferred. Is that what I do? Probably. When I'm doing pattern matching with a variant also, value variable inference variable await inferred. Okay. When I'm calling the uptime function, this is me just returning the error. So, but now in order to return the error, it's a little bit more involved, right? We just do v error into value inferred then, right? Something like that. When I'm instantiating the generic itself, we must know its value, of course. We just do inference variable await inferred. Okay. Now I'm returning these things. Shape is VArr all the time. So instead of that, we're going to do VArr into value inferred span. Okay. Next, when I'm calling a function, similarly, in order to be able to call a function, we need to know what the function is. So we need to infer it. Variable inference variable await inferred. When I'm returning the error, it's going to be the error into value inferred span. Okay. When I'm evaluating the things, I'm returning a lot of things. So in this case, I return the error value inferred span. I guess I will create a span here. Span is expression data span. I know the span now. If I try to construct a new function, I'm making a new function like so. Value inferred span. If I'm creating the generic, then we create the generic and make sure that it's inferred. If I'm constructing a tuple, then we have a tuple. If we have a variant, then we construct a variant. If we have a statement, then we return a unit. If we have an assignment, then we also just return a unit. If we have an expression type, so now this creates a type. That's inferred. If I have a native expression, this is just an error. Okay, if it is a module and I return a tuple. So over here, when I'm trying to get a field of an object, in order to get the field of an object, we need to infer what the object is first, right? So we do object, a variable, inference, variable, await inferred. Okay, return error is just, let's just do all the returns errors. It's going to be v error into value inferred span, right? Okay. If I have a field of a target value, that's going to be a string name, value inferred span, sure. If I'm trying to use a thing, it also needs to be inferred. Wait inferred. If I'm doing an if, then the condition should be inferred value already. Quote AST into value inferred. If we have a token shape, token, value inferred span is going to be here, token pattern data span, I think. Doesn't really matter though. Unit value inferred. Okay, just two more errors. Just two more errors. So this is quote AST, a child. Child is a value. This is me implementing the macros. So child is the unquoted thing, and it should evaluate to AST. Yeah, we just do child variable inference variable await inferred, I guess, here. And then this is me creating the target. Value inferred. Span is span of a camel position in this case, I think. All right. Next, interpreter natives. We have a 1,000 errors in this place too. This is basically me constructing the values though, so it should be easy, right? Okay, so we have a type, and this is going to be the value, right? Which is a type. We just do value inferred span for camel position, sure. Same stuff here. Value inferred span of camel position. Same stuff here. And then we have native functions. Values. Can I like somehow easily do this? Because basically what I want to do is I want to replace all of the things, which is like shape is equal to v something. I need this to be changed into like v something into value inferred, right? Like, and with a span, but the span kind of like depends on the place. Like this needs like structured find and replace, right? Probably could be done with some regexes, so some cursed regexes. But I'm wondering, like I know that Rust Analyzer I think has this feature, right, where you can find and replace. Do other languages do these things? Just Analyzer, find and replace, like structurally or something. Structural search replace. This is the feature of the Rust Analyzer. I'm not writing Rust though, right? There's like a documentation about this feature though. Structural search and replace. Yeah, there you go. Just the blog though. It's not documented anywhere. Just a blog on lobsters about it. Oh, it's the book. But this link is outdated. Structural search replace, SSR. This is the LSP extension. Like, I'm wondering if other languages are doing this. So basically what you can do in Rust, you can search for a query. For example, you can find all the functions that take 2 arguments, right? Or like this is finding all of the calls of a function foo with 2 arguments and replacing it with first argument dot foo second argument. And that's all the query that you need to do. How do you do this, by the way, in Helix? Do you ever do this, Nigel? Or I mean, I guess you don't try Trust, maybe, or do you? I don't really use this. I know that it exists, but I don't really need it most of the time. You do write Trust. How would you do this in Helix? Because this is not a built-in LSP thing. This is an LSP extension, so it's not like defined in the spec of the LSP, right? You didn't even know it exists. Yeah, this is like sometimes you want this. Like right now, I kind of want it, right? I at least want to find all these things, you know? And finding just using like Control F is not flexible enough, right? And this is easier than just writing a regex which can handle all of the Rust a syntax, right? Because that's a lot simpler to do, obviously, right? This is like pattern matching on syntax, right? You can see using it definitely. Yeah. So like, how would you do this in Helix? And like, as far as I understand, for VS Code, I would need to give an extra. Like, I would need to like build actually support for this for VS Code, in my plugin, right? But in Helix, since there is no plugins there, or are there plugins in Helix already? I don't know. There's other extensions in Rust, for example, that you can in Rust you can actually hover a span, which is something that you cannot do in a language that doesn't implement this thing. So like normally in the language server protocol, you are only allowed to hover a single character, but in Rust, when you're using the Rust Analyzer extension, you can select the thing and then hover over the selection and see the type of the entire result. That's something I cannot do here in OCaml. Hi, will you do advent of code with your language? That's the plan, yes. But I need to like make it possible. But we have the time. I'm pretty sure that I will be able to do it. Yeah. I mean, I did it a year ago, and I didn't even have recursive types a year ago, right? But I had more stuff built into the language, I think. So we'll see. This time I have the language server, and like it should be a lot nicer once I implement this last couple things. Alright, anyway, let me continue. I'm just doing like a big refactor here. Trying to make value inference. Value inferred. Span. Full camel position. Dun, 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 dun. Native function is this, which is that into value inferred span is span of a camel position. Okay, return error. So that's going to be error. Error into value inferred span is of a camel position. Sure. Unit. Do I do a lot of units? I guess. Unit into value inferred span of a camel position. Okay. Shape is v int 32 into value inferred position. String into inferred camel position. Character bird and camel position. Let me copy the span of a camel position. Let me actually copy a value inferred, like all of this thing. This string. So over here, right, when I'm trying to do that, we just do match argument variable into inference variable await inferred. Okay. If I am doing the read file argument variable inference variable await inferred, I return a string here, return an error over here. All right. Error here. Pull. So this is comparison value inference variable await inferred value variable boolean result error here. Actually, it's not like that long. You see the end is near. What I'm wondering though is that like with this awaits, now we have a lot of awaits, so like there's a possibility that we will have some deadlock bugs. Maybe I should have planned for inferable variables in the beginning. I don't know. Actually, hold on. One of these is DBG, though? Or did I not go over the DBG? I feel like if I try to debug print a value, then I kind of maybe don't need it to be inferred. Because I can just print in that it's not inferred yet or something. Await inferred this. Await inferred here. This and that is going to be inferred values. This is just the interpreter natives. A string to int32 and other things. Await inferred. Shape is this. And that. Okay, just 2 more errors, I think. That's what it looks like. 1 more error over here. Okay, this file wasn't too bad, but how many more files do we have? This is me initializing, like this is the compiler, so in the compiler we just have some constants. And in order to do the constants, now this shape, this is a type. Wait, what is this even? Instantiating generics, I see. So this is the value. Then value inferred span. What's the span here? I guess I'll use this current span. Import is a constant where shape is unit. Not of a camel. In this case, we just use the span. Value is error. And no recursive imports. Yep. Okay, now core syntax has a couple of places when you have a placeholder. So now the placeholder now, right? This is going to be different. So previously in the language, I only could use the underscore in type position, but now I can use it in a value position too, right? So previously I only could do like let x, which is non-inferred type like this, right? But now we can just say that let. I mean, we can already do right now that let x be equal to underscore, but this was like this was the not inferred type, but now this is not necessarily a type anymore, right? That's the difference. So over here, I was always initializing a new not inferred type, but it's not necessarily the type anymore, right? It's just going to be a value. It's literally just a new constant, a value. Wait, is it even a constant at this point, or is it should it have an expression that generates a new thing all the time? every time I evaluate the thing. Like, let's say that we have a function. Like, I want to be able to create a function that like just creates a new thing, right? Like, what should this mean, basically, right? We have a function that takes nothing and returns the new not inferred thing, right? Should this new not inferred thing be a different not inferred thing or the same not inferred thing? That's the question, right? If I call this function twice, is this two separate things or is it the same thing? Right? Because, like, technically, should it be different if I say let x be of type underscore and like y of type underscore, right? And so this allows these two things to be different types, right? But then I can say that if this is const not inferred, right? Let's say n, right? N is a function that returns new not inferred thing. So then we say that x is of type n and y is of type n, right? So this is kind of like the same thing, but like I'm calling this function twice. This should mean that it's two separate, two still different types, right? Because the way it works right now, because it's a constant, it would be the same type for x and y. Like different. I feel like both of these designs could work. I'm not sure what I want though. Let's have let's have a constant for now. I'll do a to do here. Maybe have expression placeholder. Like, I have an assignee placeholder and a pattern placeholder, but there is no expression placeholder. So yeah, we just have a value, and the value is value new not inferred. That's it. New not inferred value in the current span. That's all. And then if we do the type, then if it's a type expression, then we create a new type here and everything. But technically, I can just have a type expression. And where this expression is going to be just compile a compile expression AST, because that's just going to use this existing thing already. This is compiler. I change this compiler to be just C, just like in all the other places. Sure. Okay. I'll think about this more. Let's just continue this. So we have a constant where value is unit, because that's the syntax for the unit. So we have a constant unit value inferred span. There we go. That's all. If we have a type, C compiler is such a misleading name. No, c.compile. It's not compiler. C is the compiler, and compiler can compile, right? Still misleading. What would be a better thing? I cannot call it compiler because compiler is the actual module. Like that would be clashing names. I need to have two names that are compiler. So I'm calling one of them compiler and one of them is C. C is like the variable of type compiler S. There is like also this. So like I don't know if you have gone this far in OCaml. This is also another convention, I guess. So for types you do like module.t, and for module types you do module.s. S for signature, I guess. And then there is more conventions for the functors too. Like I don't know, I'm not a big fan, but I don't know how to do it better. It compiles to C-lang. Oh, C compiler. Oh, you mean like we compile C code? I don't think that's misleading. Why would you assume that I'm doing C? No. Okay, over here we have a type, type value inferred span. Okay. That's easy. And over here we have a type expression, constant expression, type. Wait, what? This is type. And is this type is inferred that. Yeah, whatever. Yeah, there's just like a type without the arguments, right? Is the type with arguments something different? I guess. Oh, Spike, good morning. Making a programming language looks inside. Wait, what's inside? This is a programming language. What's wrong? What do you mean? I'm making a programming language in quotes. Okay, boolean false into value inferred span. Boolean true into. You know what? I'm going to right now actually say that's true. That's true is boolean impl true. How about that? And false is boolean impl false. And I'm going to reduce the copy pasta here. That's good, right? Look, no copy pasta anymore. Name and value is this. So this just means that this is going to be not. It's going to be value, right? And this, not that. That's going to be. That's going to be name. And name is just name. There we go. Nice. Type is not even used here. It was copy pasta from before, I guess. Okay, now when we have, what is this? We have a dot syntax, right? So we have a dot syntax. I'm trying to see over here, object shape. Object is, I'm trying to evaluate the object expression. What's happening here? I'm trying to compile the dot expression. We have object and the dot field, basically, right? That's the syntax that I'm trying to compile. And then we see that the variable that if we see then that if the type of the object is a compiler scope, Yeah, this is like some hacky thing. Let's do object variable inference variable. Let's do inferred opt here too. So that should be like some compiler scope then. So in this case, I don't await. I just see if it's inferred right now or not. Okay, constant unit. This is what? This is implementing the syntax, whatever. Unit value inferred span. Sure. If we have, I don't know what's happening here. That's still implementing syntax value inferred span. And over here, this is the quote, which is for quoting ASTs. That just gives me another constant of AST value in third, where span is AST.span. That's the recursive thing. Okay, yeah. Injecting the context. Injecting the context. I'm trying to see what's the context type here, right? But the context type here is not necessarily known yet. Maybe. I mean, it was known previously. Maybe it's fine. I just do context type variable. Inference variable. Do I do a wait here? I don't know. Let's try awaiting. Same here. If we do current context type of variable. Inference variable, await inferred, sure. Binding shape. Binding compiler val. Binding dot var into inference var. In this case, I don't want to await. I'll just see if it's a binding immediately like that. All right. If we have underscore file, there's just a constant of a string, which is the current file. And then the last error in this file, at least, is this one, when we have the current compiler scope. Okay. Value inferred span. Okay, next. Next we go into the compiler over here. All right, so what is this? If I have a string, then the if I have a string literal in code, then it's just a constant where we have this value. Value inferred span. Sure. If I have a number literal, then it's right now an integer. Sure. Integer value inferred span. Sure. If we have this thing, we have a custom syntax implementation. That's just some AST business happening for the macro arguments. Do I give you the AST span here? Maybe. Probably. That's what I give for the type inferred here, at least. Okay, argument is a tuple of these. Value inferred. Span is that. And then result, we just evaluate this expression. Wait, what's an expression here? A constant impulse, constant arg. Yeah, we just call the implementation with the argument because that's just a function. A macro is just a function that takes ASTs as arguments. Sure. And then over here, this should be available immediately, right? Result. Var inference var. Let's try not awaiting here for now. AST is a tuple. AST span. Unbound record field. Why is the record field bound here but not here? If this is the same variable. Hello? What? Unbound record field span? Because it doesn't know what this is, right? And what is this? This is AST, right? What it is. Okay. All right, and then the last error in this file is this. We have a constant unit. This is the syntax without any value after. We just returns a unit value inferred span. Okay, that's nice. Next, we have the Okay, I'm almost there. And we have a transpiler. In order to transpile the values must be inferred, right? So value var inference var inferred opt with some shape, then match shape. And if it's none, then I'm going to fail. Let's just do fail with lock here for now. I'm not even sure that I'm going to continue with my idea of transpiling my language into a camel. Maybe I'll go back to JavaScript. We'll see. All right, so this is just the REPL, okay? This is just the REPL, so if a value for inference for inferred opt, if it is inferred to be a unit, then we don't do the printing, otherwise we print the value. Yeah, sure. Okay, it is all compiled. Do you think everything is still going to work? I have no idea. Probably not. What's going to happen? No? We have unhandled effect await update of the inference variable. Okay. Prediction. So I'm awaiting. Actually, I mean, it should be in this, right? But what about, like, let me just try cast like this. Okay, cast works. Okay, which means that standard library was parsed properly, right? STD is still the thing. I still see all the things in my standard library, right? Okay, let's try use std io. Let's use std prelude, right? That's my REPL here. Okay, so print hello. That doesn't work anymore. All right, now nice. So I cannot print hello. Okay, so which means that I should not be able to run even examples hello, right? Yes, okay. Why not? So it's because I'm trying to substitute the bindings. Because I'm expecting this to be a type. And because I'm expecting this to be a type, expecting a type is trying to await the thing. Substitute time binding with a non-type. Value is not inferred yet. Interesting. Wait, but what exactly? Like, what exactly is happening? I'm not seeing like because effects are not exceptions, I guess. Yeah. Okay, so maybe I should just have a default handler for the await update. Because okay, yes, await update. But what should happen? Handle effects, right? Like if I have an effect of a inference is cast inference. So if inference variable await update, await update. This should be then specified in the interface here. So if it is that, I feel like I should do effect discontinue continuation using an so I need to throw an exception in this case, right? What's the type of this? Await update. This is the inference variable that I was trying to wait for it to be inferred, but it's end up never being inferred, right? So technically, I guess maybe technically await inferred should return the fact that it's not inferred. But for now, let me throw an error. Failure variable is not inferred and cannot be awaited, right? Something like that. Okay, so this means that I'm actually going to throw this exception though, right? Okay, I am actually throwing this exception, which happens inside, let's see, find target dependent branch, this, and that. Like, why don't I see the stack trace of my cast code though? Because I'm trying to evaluate something. Oh, because I never do this. I never did that, right? I only have a while compiling, right? I have this thing while compiling, but I don't have the logs while evaluating, I guess. While evaluating. Yeah, I don't have it. So I just have this thing in the interpreter common, I guess, when I'm evaluating an expression. That should just do a try here. With exception. And then while evaluating, that's going to be while evaluating do you have expression? I can only print it fully, so while evaluating, and like a print short thing similar to the ASTs. While evaluating this expression over there, right? So we just do expression, print short, expression, and then we do span, print expression, data, span. Something like that. So just what is an expression print short? Print short, print expression short. It's not really recursive, but I will wrap it in cache like everything else, I guess, anyway. First expression short. No, that's that type expression. And normal expression. Print expression short. Expression shape unit. This. No, this actually takes expression, so I'm going to function this expression into match expression shape with, right? Okay, and then we just do. Can I do that easily somehow? I guess I can remove this like code in the middle. And then I just go for all of these. That underscore into this. Right? That's what I want. Let yo, what are you working on? Hello, right, Alex. I'm making my own programming language. Hi. And I'm improving my inference to work with more things than just the types. I'm still on it. Yeah. It's going to take a while. I'm going to be on it for a long time, I guess. And unless I drop it for some reason, but it is, I don't know. This is the most addicting project ever that I ever started. I don't think, like, instead of dropping it, one of the other things that I can see is it's probably going to be not a drop, it's going to be another rewrite, right? That's going to happen for sure. I mean, at least one more rewrite is coming, rewrite of the language in itself, but maybe for some reason I will like, I mean, like maybe there's going to be multiple rewrites in itself, right? I think I will get to the rewrite of the language in itself. We'll see then. Will it be closer to a specific language, like C or something? It's going to be a mix of languages. Not C, no, not C. Right now I'm focusing on the high level features, but I guess the closest one, the closest languages are going to be like Rust. Although syntactically I'm doing like different syntax, I'm getting a bunch of things from functional languages. So I want to have a good type system. So like Rust, Haskell, like that stuff, I guess. I don't know. There's this feature called comp time, which is the feature from Zig, I guess. Although Zig is not the only language that's doing that, but you know, it's more popular than those like dependently typed functional programming languages, I guess. I haven't learned Rust in Haskell yet. I hear Rust has a whole memory safety thing. Yeah. So I want it to be safe too. Yeah. Like eventually, like in the long term, I want this language to be both high level and low level. Right now, I'm focusing on the high level part, so which means that I want to be expressive, but like very type safe. I want to have a lot of guarantees about the code that I'm writing, right? So, for example, can my code throw an exception randomly? Only if it is specified so, right? Now that specification can be inferred, but I should be able to guarantee that certain code doesn't like explode on me, right? Yeah. So since you have not learned Haskell, I guess you don't know what a monad is, but Haskell solves that with monads basically. Kind of, and I'm going to do an effect system instead. FN rocket with no explosions. Yeah. So like basically enforcing the a lot as much things that we can, like encoding as much things as we can, not in the documentation but instead in the type system, right? So that it can be verified easier, right? Like just prevent a lot of as much bugs as possible at compile time. All of my experiences into C++. I've started only a year ago, so I'm planning to learn Java soon too. All right, good luck. Good luck. Okay, this is just the name, I guess. And then I just print ffmt %s name, maybe. Sure, let's do that. Wildcard parting into is an argument to a constant constructor. Actually, and this is just a warning, this is not a thing. I'm wondering if I should do that for my language, but I don't know if I can. This is kind of nice, being able to do that. So like, you know, we have like a variant type with no associated data, and we still are allowed to use it as if it has data. I'll think about it. Finish the language in 3 days and participate in Honest Gem 8 with the root right. There's an Honest Gen coming on December. Okay, I'm doing this while evaluating this function. Okay, this function while evaluating this. While evaluating this function expression. Oh, because because I'm trying to instantiate this. Yeah, I've instantiated this generic. Makes sense. I bet you already planned something for that, but what would make your language cool if it's compatible with XYZ languages? Language compatibility. Language compatibility. I just made it up. Yeah, I'm not thinking about it right now, but the idea is that I should be able to transpile my language into other languages, right? So maybe that's how we get the compatibility. Maybe? I don't know. Like, one of the ideas is to be able to to be able to write your own custom transpiler easily. I'll give you like the tools to do that is the idea, which means that you should be able to convert your code into any existing programming language, so that you can embed it in your existing like thing. But it cannot be like compatible with multiple languages at the same time, right? This way, because you only will transpile to one thing, not to the other things. Unless you do like actual like interop like Lua into C++, that's a little bit different, because you don't convert your Lua code into C++ code, just run the interpreter there. And the interpreter, like in that case, it is already compatible with all the languages, I guess, because I am writing an interpreter, so it can be used just like Lua, I suppose. But we will need to like to expose the API, how to like get the values in and out of the thing, I guess. But that shouldn't be too difficult to expose like a C API, and then anyone can write a wrapper for it for that language. Using it as a scripting and language should be like the easiest thing. I'm actually using it right now as a scripted language already in my bot. If you do this, then this bot is replying using a script written in my own language already, but the old version of it. So that's written in Rust technically, but then it's embedding it as a scripting language inside. The bot is written in Rust, but then some of its logic is written in my own language. Can't wait to use casted scripting language inside of a cast game engine. Yeah. All right, we have the bug here. What? I recently met with my girlfriend's dad, and I pulled out the. You didn't tell me you had a younger sister on her dad out of nervousness. Cast game engine Loki sounds fire. What, Ball City? Hello, Tommy Luco. All right. I want to figure out how this. What's the problem here? So I'm trying to evaluate this expression. And then it says that the value is not inferred. Handle effects. Maybe I can like print the variable here, like the span of it or something. Or what's the variable that I'm trying to infer, you know? Variable. At this discontinue. Is there like a discontinue with? There is effect continue with. Continue with a function where I fail. Yes, that sounds good. If I fail this continuation with a variable over here is not inferred and cannot be awaited. This is span print inference variable spans. These are all the spans actually, yeah. Do I print all the spans? Spans of variable into set and set to list, and then over here I print list print. So I print all the spans where this variable is, although there should be only one there, I think. Usually when you meet the mom, you say, you didn't tell me you had a younger sister, as a compliment to the mother. And you said that to the dad. All right, yeah. English is not my first language, so I never said that to a mother, you know. But I guess it happens. in countries where people speak English, maybe. I don't know. I think Linksider was already Turing complete before all the side effects were added. Um. Exception variable at fake sub var. Oh, of course. This is useless. Oh wait, fake sub var and fake to do. Wait, we have actually two inference variables. Okay. Is not inferred and cannot be awaited. Fake to do. My first language, I'm Russian. Or you mean, yeah, cast is my first language, I guess. Indeed. The first language that I'm making. The first language that I was using was actually Python. Um. So what do? Fake to do. I need to like get rid of these fakes so that I can understand, right? Let's see, fake to do. Um. Fake to do. Wait, that's literally in. Wait, is that in the only thing? Where we quote AST? There's no way. Now. To do. Quote AST. Why is this even a to do? Yes, this is it. What? So I'm quoting the AST and I have expression quote AST. And that returns an AST. And for some reason the span is fake instead of being the actual span, which is literally expression data span. Oh, that's expression shape quote AST, right? Oh, I had to give it the span. Let's give it the span here. Span. That's going to, and that's used over here. We have expression quote AST, and then over here I just say span. And that's all? That's all that I need to do? Okay, so what's my span? This is the span, okay. This underscore. Okay, I see it. So yeah, so the reason it works is because I'm using the equals. Equals is being expanded into, like, this is a macro, right? So the equals is just syntax sugar for me calling this, and this is a generic function, and I'm using the underscore here. Okay, that makes sense. Off topic, but don't you get tired sometimes of for doing whole streams in your second language? Sometimes I get tired of consuming content in English. Nah, not really. I don't know. I like English. I'm using English all the time. I mean, I'm consuming content in English all the time. Yeah. And by streaming, I'm also practicing my English because I guess I don't like really talk in English outside of the streams, but I consume the content in English all the time. Yeah, I've been doing it from like from the very young age, I guess. We were playing. I was like I started learning programming a long time ago, right? More than 20 years ago. And back in the day, basically, there was like, if you wanted to learn it, you had to do English because there was a lot less material to learn programming then. So like I had to learn it anyway, you know. And then also I was like playing games, and a lot of games, they were not translated. Like all of the translations, they were really bad, so it is a lot more enjoyable to play the game in its like original language, I guess, right? The games that I was playing, they were never like story heavy, so I didn't really need to translate much. But yeah, that's basically how I learned English, I guess, by learning programming and playing games. Yeah. But they were teaching us in school English also pretty well, I suppose. Personally, I mostly feel more comfortable in English than my native. I don't know. I was trying to talk. Like I was thinking that maybe I should teach my kid English, but like trying to talk to a child in English is a little bit different, because like normally I like speak on technical stuff, right? About programming or whatever. But trying to like speak about like something that's unrelated to that, I don't know the words, I guess, anymore. But yeah, they should grow bilingual. Like I feel like it's really like easy at the young age, right? And I'm wondering, also, like, you learned English through Roblox when you was a kid, yeah. Like as like AI progresses, there's going to be less and less reason to learn other languages, and I mean, even now there's a lot less like reason to learn English compared to 20 years ago, because there's a lot of materials that are already localized, and then just using the translation tools is also easy. So because of that, like kind of a little bit forcing English into the child is, but by talking to them in English from the very beginning, maybe a good idea. But yeah, well, like we have a couple books in English, so we do both languages, but I don't know, it's like difficult, to try to force to speak myself in English, like at home, because yeah, also translation tools go so much better nowadays. Yeah. But I feel like knowing another language is still like a good thing, right? It's basically I think like knowing English is the most useful skill that I have, I guess. You just have to start, and it will get more comfortable quickly. Yeah. I mean, I'm kind of like, I have kind of started by reading the books sometimes in English. Yeah. Anyway, let's continue here. Will newer generation will become dumber and dumber on average because of AI? Yeah. Just look at schools, they're pushing AI, and students want to use AI to do their homework anyways. They don't learn to retain anything. Yeah, that's what I mean. That's why, like, forcing it a little bit. Like, but I need to force myself, right? I don't think the child is going to have a problem with it. I have a sister who has bilingual kids, I think. I heard it's really easy for the kids to learn 2 languages immediately. All right, so yeah, what's happening here is we have this underscore. Underscore is now not just the not inferred type, but it's a not inferred value, right? But in this case, it should be a type, right? So what we should do is this. So we have values, and values, they have associated type with them, and basically once the type of a value has been inferred, we potentially have inferred the value, right? So because if a value is not inferred, right? But we know that the type of the value is type, then the value is actually some not inferred type, right? And if yeah, and some similar stuff, you know. So once you know the type of a value, you can initialize your value to something immediately. Will you teach your child cast as a third language? Yeah, I guess. Maybe when she's grown up, cast is also already going to be like mature and used worldwide, so everyone will learn it, of course, including my child. Right? Yeah. So value. New not inferred. Here's what we need to do, right? So when I'm creating a new not inferred value, I know that the value variable is of type new not inferred type, right? But once this type is inferred, then we can infer what the value is. That's the idea, right? So let's say this type is this. So we do that, right? We do that, and then we do that, and then we do something like type inference variable once inferred. So once the type is inferred, we can assert something about the value. Right. So this is going to be function type shape, and then we want to I want to say that match infer value shape for the type shape. It's going to be either inferred or it's going to be not inferred. If it's not inferred, then I'm not going to do anything, but if it is inferred, then I am going to say that my variable needs to be inferred as span is going to be fake. Infer value based on type, like something like this, so that I understand what's happening here. So we infer this as a shape. Question was as type inference variable infer as. Oh, I need to tell it how to unite these things. Okay. Inference unite inference. Wait. Oh, this is just the type. I cannot do it here. I cannot do this here because the inference is not defined yet. Wait. I have this like recursive dependency problem again. Like yeah. I can move this to a different place. Or I can move this code. Oh, wait, yeah, I don't... Okay. Types. All right, I'm not going to worry about too much, but this library over here is handling too many things, so it's going to be some inference here, I guess. Maybe I just write it directly here then, you know? Yeah. So this should be infer as using infer value unite value shape.unite. Yeah, how about that? We have module shape and we have value unite, which is inference unite of shapes. The programming language you use. This on the screen is OCaml. So when I unite, this means a function AB. Yeah, so now I need because now I need inference for values, right? I need to make sure that I know how to unite them. Yes. We need to just match A and B, and this also takes the span, I suppose. Width, and now we need all of these variants. So what needs to happen is if we have two values which are both units, then return a unit. That makes sense, right? If we have two booleans, but unit should not unify with anything else. Fail. That's literally the same as we do for the types over here. Fail is yeah, let's just say that error. And then what is error? Inference.error. Inference.error. Sure. And then we that's not type shape. That is just T, I guess. So there's going to be a value error. Print A and print B. Like this. Okay, so this is just the inference. We know that unit can only unite with a unit. We know that a boolean can only unite with another boolean which has the same value. So when A is B, then the boolean A. If we have maybe let's just try this manually here. Right. I'll keep that on this screen so that I know what are the other things that I need to do. We have a boolean and not a boolean, then we fail. Integer A, integer B only unite when A is equal to B. Let's do that. Characters work the same way. Strings work the same way. Tuples are going to be a little bit different. If we have types, if we have shit, what did I do? If we have type A and we have type B, then we're going to get type where these two things are united. And now I need to actually move this logic. Oh my god. Hate that. And it's also all going to be recursive at some point, by the way. Yeah. This is unite type shape. I need to move that, and I need to move the uniting types over there. Sure. I guess I just have the inference here, you know, something like that. And then this is uniting the type shapes, and I'm going to unite the other things here too. So we have uniting of the types, we have uniting of the values. Let's unite value shape. This is value shape. Unite this value shape. That's going to be print value shape, print value shape. This is going to open print, open types, open std, open utility. I have a syntax error here. Does it do fail here for now? But this over here is actually to do. And this one is also to do. Okay, so now if I have two types, then we have a new type where type is unite types A and B. Right? Unbound value unite type and unite type. And unite type. And unite type shape value. There is syntax error still. Where's the syntax error? Over here. Native function. Native function. Fail. To do. It would make sense to unite two functions though. Right? Let me just do this one immediately. Result type is a type. ID is IDA. And unwind token result type is a B type. Is type B, and this is type A. ID is IDB when IDA is IDB. Unwind token result type. Unite type. Span type A, type B. ID is ID. Okay, we just do that for now. All right, unite. Unite is inference unite, right? Okay. What else do you want? Dependency cycle. Oh no. Oh no. I think it's because I called it inference though. If I call this inference implementation, then there is no dependency cycle. Okay, yes. So we do over here, new not inferred. This is not... Wait, what is this? Infer value shape. Oh, yeah. Infer value shape is like the other thing that I'm going to need to do. Infer value shape. Maybe I do shape infer. How about that? So we have a shape infer, which takes a type and returns shape optional function type into it returns that's type shape, I guess, right? I'm going to have a function here. Function type into, let's just do none for now. Like that. Okay, shape unite. Inference impl unite value shape, right? That's what I want. File none line 1. Wait, what? File none line 1. That's a beautiful message by the OCaml compiler. Unbound module tie. Yeah, because I use tie here, right? Tie dot. Yeah, because instead of this, we cannot do that yet. Type shape. Camel restart language server, please. Can you like... That doesn't work. Because it needs that first. Tie dot. Type inferred. I cannot do type inferred anymore. Here, right? Oh my god. OCaml. And to move things out of here, I guess I need to... Like, I need to also have in this same thing, inferred type, shape, span, and shape is this. That's inferred value, by the way, right? And then when I want inferred type, span, shape. So this over here is value, and this is type, is var is inference, and in this case inference is cast inference base, right? Inferred type, inferred value. So inferred here is inference impl inferred value. Sure. Maybe new not inferred also goes there. New not inferred value. And new not inferred value span is this. Okay. And this means infer value shape. So that's going to be infer value shape. That's type shape into value shape option, right? Unbound module type, tie dot. Yeah, so this is going to be new not inferred type, right? So we need to have a new not inferred type here too. It returns type. So that's going to be just var is inference var new not inferred span. I think. And then type new not inferred is inference impl new not inferred type, and then inferred is going to be inference impl inferred type. Okay. Unbound module type still type dot. Yeah, because type shape is now type shape. Okay, and now we have just unbound value error. Okay, nice. Inference let error be inference error. Like that. Nice. Unbound module type again, and file none. Why is there file none? File none. I want some file. I don't want none files. Is it this file? It is this file, okay. Type inferred should be inferred type instead. Okay. I still have this. Type shape print. Should be a print type shape, I guess. Just create the file. Unbound module var now, var dot. Space var dot, var unite, inference var unite. Okay, nice. All the modules are there. Now we can continue with the actual algorithm of the uniting value shapes, but this is like very annoying. It was very annoying, but like it's also because of the recursive nature of my language, I guess. But it's very hard to split things into like without having dependency cycles. Okay, so if we have types, that's already handled. If I have a type and not type, then we fail. Why is there an int here? If an int was already here, if I have a function, if I have two functions, then we fail. If a generic, then we fail. I don't know. We'll see. If I have two ASTs, let's just fail for most of these for now. Target. Fail. Context type. Fail. If I have two bindings probably should not. Actually fail. It's going to be similar to types. Compiler scope and being inferable is weird. And we have error. Yeah, if we have the error, then it just unifies with anything else and they become error. The error and whatever. Or whatever and the error. Just returns an error. Oh, wait, no. It returns something that is not an error. Like the other thing is being returned here. Okay. Okay, now some spaces here. And now we have unbound module shape. Shape dot type of, which means that type of, okay, needs to also be moved. This. Let type of be inference impl type of value shape. Okay, and type of value shape is this. Unbound module shape dot type of value shape. Okay, module inference impl is an alias to cast type inference impl, which is in the current compilation unit. What? Excuse me? What does this error even mean? The module inference impl is an alias for a module which is in current compilation unit. What does this even mean? What the fuck? This means, camel. You essentially named a module the same thing as the file it's defined in. Oh, wait, am I actually doing that? I'm just, yeah, I'm using like this thing inside of itself. Yeah. That makes sense. Unbound module type, yeah, and then type of this. Now type inferred should also be inferred type, right? Okay, it worked. It worked. Now I just need to fix the other things. Need to like re-export this or something. Inference impl is inference impl. Can I do that? And then over here I say let unite type is inference impl unite type. Okay, this should like give me back, get me back. Okay, now is this going to work though? Let's see what's going to happen. It's going to be the same error actually, right? Yeah, it's going to be the same error. And the reason is because I did not implement this thing. The last thing that needs to be done is infer value shape, right? So if I know the type, then I can know some of the value basically, right? Yeah, so this is going to be a function, and we have a bunch of types. Like this. These are the types that I have. I need to take a break. Back. All right. Yes. So we're trying to infer the value shape based on the type, right? If it's a unit. So if the type of the value is unit, then the only possible value that we can have is obviously a unit, right? If it's a boolean, then there are multiple possibilities, so we don't infer anything here. If it's an integer, same thing. If it's a character, and same. If it's a variant type, then we also, I think, don't infer anything. If the type is function, then we don't infer what function this is. No. If it's the type is generic, then we don't infer the definition of the generic. If the AST, it's mostly like none for all of these. It's none for most of these. But the one that is interesting to me right now is the type, and then there's also the tuple. The tuple is another interesting one. So if we infer the type, if we know that the value is a tuple type, then we can initialize its structure already, right? But I'm going to have a to-do here. Actually, never mind. I'm not going to do a to-do. Let's do it immediately. But the easier one is the is going to be a value tuple, you know. But the easy one is the type. So if the value is a type, right, then it's a type, and we initialize this to a new not inferred type, right? Yeah, just a new not inferred type. I guess I kind of want to, like, because these guys need spans. Let's give it this span then. This is going to be some value type, and there's going to be some value tuple. And in this case, since we have a tuple, I'm just going to say tuple is tuple map. We have field, which is type tuple field. And I need to return value tuple field, right? And what is value tuple field? A value span and type field. Type field is field. Span is field span. Value is going to be new not inferred value. And maybe just use the original span here though. Yeah. That's how we infer the structure of a tuple. What this will allow us to do basically is that if I have code like this, you know, do generic, and I instantiate generic with an underscore, but generic is actually a generic that needs 2 arguments, then I don't need to do underscore underscore, because we know that generic takes arguments, so the type of the single argument of the generic is a tuple of 2 fields. It's going to replace single underscore with 2 underscores automatically, which is really nice. And you can do it recursively too. New not inferred value. What is this? Oh, I need to give it a span. Yeah. Maybe? That's it? Let's try running the code. Is not inferred and it cannot be awaited. Have like a generic score. I don't know if you actually want that. Wait, what? What do you mean? Is there a way to only match on a single argument? What do you mean to only match on a single argument? Something like generic this. But like, it depends on the definition of the generic, right? If the generic takes a single argument, it's only expanding if the type of the generic argument is a tuple of 2 things, you know? You change the type you want. So like you change the type, you want an error maybe? What? Oh, so that's like you basically, when you see code like this, you assume that this is a single argument. But I mean, that's what I'm saying. We always, so like, we have functions, and generics are basically functions, and all the functions have a single argument always, right? And if you want multiple arguments, then it's a tuple, right? Then it's a single argument that's a tuple. So in this case, we are inferring the argument that is a tuple, right? How's OBS on Hyperland? I didn't have any problems with it. Capture keyword input. Yeah, I mean, I guess there is like the Wayland stuff, right? There are issues with Wayland. Some of the things are annoying. It's hard to get it working on Switch, so maybe Switch. What's not working though? Like, there are a lot of features in OBS. Some specific captures. Okay, window capture. Let's try. Let's see it here. Let's go this way, right? So we go to we go here and we add like window capture. It's just called screen capture is the thing. Maybe that's what you are not understanding. In Pipewire, like this is what you should be seeing. It's called screen capture. But the thing is, it's called screen, but you can select a window here, right? So here's, I'm going to select the OCaml, and then I'm capturing the OCaml, you know, window. Like, I mean, the Firefox window. I had to build head to force way to even have it. Yeah, I don't know. I'm using Nix, so I'm not really like, it's whatever the package manager is doing for you. Maybe. What Linux are you using? I thought you were on Windows. Did you ditch Windows? There's no way. You're on Ubuntu? Yeah, I don't know. It depends on like the distribution, how they package it, I suppose. Because there are some flags that you can set to support certain things, right? Just building yourself, alright. Yeah, I never did that. Boom, boom, boom. Also, Niri is the new thing. But it had like I had some issues with Niri myself, so I moved back to Hyperland. But Niri is the new like fancy window manager for the cool kids, you know. Is Niri WL roots based? Do you need it to be WL roots based? And I don't know. I don't think so. Niri is written in Rust. I don't know if that makes a difference, or if you can still make it based on WL roots. That WL roots is like the library, right, for creating the window managers. So I don't think so. But I have no idea. Also, I've been using just GNOME with the tiling extension. It was working relatively well. I used the Forge extension on GNOME, and on GNOME everything works with no problem. I never had a problem with GNOME, I think. I don't remember, at least. But the extension for tiling is a little weird, so yeah, I guess tiling is the thing that is not working perfectly there. I was thinking of doing X11 with i3, but the capture is limited. You got a new laptop with a high resolution and you cannot configure your monitors on X now? Because it's too big for X. X server has doesn't support too big resolutions. Is that really the thing? Okay, it still is the issue, by the way, that this thing cannot be inferred. But why is that? Is this inferred to be a type? I want something. I want some simpler example. Let's go to hello world, right? Let's comment this. Then it's going to run, right? So like this runs. How about I say 2 equals 2? Now that doesn't work, right? So 2 equals 2 is std cmp equal underscore 2 and 2, right? There you go. So this doesn't work. Now this thing is not inferred, right? Yeah. But we know that the type of this is type. Or is it because I'm using the old... Oh, wait, yeah, see? So now I'm hovering on this underscore, and it says that the type is underscore, which means that I never set the type of these things. Even although this is type, right? So we know that this argument must be type. Yeah. So I need to unify the types when I'm inferring these things. Let's see, is this when I am initializing a generic thing? Init expression instantiate. We have a generic and we have argument. We have argument which is just evaluated, but I cannot just evaluate it here. And to first say that the generic, that the type of the argument is the same as the type of the argument. That's the definition. Yeah, definition. This is a compiled function. I need to wait for it to be compiled and then evaluate the argument, by the way. And so since this is compiled now, and on definition argument is a pattern and its type is equal to my argument type, right? So I say that type inference type. So argument type, we need to that to be inferred as where span is argument data span. It should be inferred as definition argument type. You're back. Welcome back. Okay, let me try again. This is going to work. Guaranteed. It was not guaranteed because no target dependent branch matched. Wait, what? That makes no sense. Can I print the... Wait, what? No, that makes no sense. I think it's because native equal doesn't work anymore. Yeah, that makes sense. This function doesn't work anymore. Because let's see. Equal over here. This is just using the equal operator, right? But the equal operator, this is the representation equal, which is using the OCaml internal representation, which I changed. Right? So I have this operator. And I'm just using this on the values. And these are just values, right? But these values, they must be inferred in order for me to be able to compare them, right? Otherwise, that makes no sense. A value. Just do A and B, right? Let A be a value var inference var await inferred, and then same for B. Okay, so I'm finishing the thingy. No, I'm in the progress and in the process of finishing it. I did not finish it yet. Okay, this works. There's no way. I fixed everything. Right? Hello world is working. And then how about the lists? If lists are going to work, no, I still have the type checking issue. Wait, but and that's the different one. Yeah, and that's the different one. But here's what we can do, right? So now that this works, I can write something like this. Let function f this is a generic function from like for types A and B, right? And this returns, and it's like takes function like argument A, and it takes argument B of type B, and then this returns I don't know. Let's just say that this function does std dbg print A and print B, for example. So like print both A and B, right? So now I can, previously I had to call this function by doing underscore underscore. One hello, right? But now I can just do it like with a single underscore. No, I cannot. Okay. This is not inferred and cannot be awaited. Wait, what? Why? Oh, I know why. I know why. That makes sense. Wait, no, it does not make sense. Wait, does it make sense? Let me take a look. Print simple. Infer value shape, right? Yeah, no, it is not a new not inferred value, which also should do it recursively. Yeah. Okay, well, it doesn't work, but it's supposed to work. Why not? Like, it's the same thing, right? Oh, wait. I think I know why. I inferred the fact that it's a tuple, right? But I have not unified the type of this, like this value should be of the type of this field type. Yeah, there you go. Like when I say the new not inferred value, I potentially can give it the type still, right? So I want something like this. New not inferred value of type. So that's going to be value is new not inferred value on this span. And then I return this value, right? But then I also say that I also say that unite types, value type and the type, right? Ignore that. And then I give it this span. So when I am creating the tuple, this should be not a new not inferred value, but new not inferred value of type field type. There you go. That was the missing connection, I'm pretty sure. And it works. There you go. Nice. So this is kind of important because we want this, like we want technically this code to just look like this. We call function f with these arguments, right? So I don't just have the auto instantiation yet, so I need to do this explicitly. But that's like a simple desugaring that I will need to do if I'm trying to call a function, but I see that it's not a function but a generic. Then I am going to auto instantiate this and automatically insert this application, and then it's going to be actually like looking nice, right? Like I can just print a instead of print underscore a, right? That's how it's supposed to look. So value inference kind of is there, I guess. Fixing recursive generic types, I don't know if I'm going to do that right now. This is good progress, but I feel like the other thing that I need to do is that where's my handle effects? I just want, actually maybe I just do the auto instantiation right now because that's the really simple thing, and that's going to reduce the noise in the syntax easily, right? Because this fixing recursive generic types is still I feel like that's the difficult one. But what I want is that if I want to update the variable to be inferred, I kind of just want the variable to be like in this case. I don't want to. I never want to panic, right? I want the language to continue working. It just should be inferred to be equal to an error, I guess, in this case, right? So await update returns unit. But maybe it should return like false here. And if this is false, yeah, I like it. I like this. This is going to return Boolean, whether we should continue or not. And by default, I'm going to return true. So if I waited for the update successfully, then I just go into the loop. Otherwise, I'm going to return the error, which means that await inferred, this needs to know how to do an error. Error shape. I need it to tell how to do the error. Error shape is a so I just return the error shape. Literally. But that also means that what's the error? Oh, because the error shape, yeah. So await update should have error shape a. So now but now we need lists that are errors, and that's something that I don't have yet. I need to have row variables which are errors, and I mean I should do that, right? We should always have error. Yeah. So I guess if we have some error for printing the rows, I'm going to print error, right? Okay. Unite shape, if we have error and something or something and error, I'm going to return something. If we have await inferred to list, if I have inferred it to be an error, I guess I will also give it the empty list. Await inferred error shape is error, right? So yeah, dot var into inference variable and weight inferred. I guess I should be doing await inferred. Let's just say that await inferred value into value shape is function value variable into inference variable await inferred, where shape is value error. Where error shape is value error. This is row shape. You wrote the interpreter in OCaml and now rewriting the language in cast. I'm not rewriting it yet. I hopefully will be doing that soon. Ish. But it's I'm trying to prepare for the advent of code first. So after the advent of code, maybe like next year, I will start the rewrite of the language in itself. Right now I have the interpreter in OCaml, yeah. And yeah. And this also has been written multiple times. This is a rewrite number 3 technically. I had yeah, I had 3 rewrites already. So the next rewrite hopefully is going to be the language itself. Activate Linux. What? Lol. What? Linux? Activate? Huh? Huh? Wish to get to your level someday? I don't really know what I'm doing. I'm just going by intuition, I guess. I don't know the theory here. Just, you know, just figuring it out as I go. There may be some stupid mistakes in the way I'm doing things, but I'm already impressed with my own language, to be honest, with how far I've gotten, you know? Like, a lot of the things work already. That I thought would be more difficult. I've heard the quant firms use OCaml. What are the advantages of the language? To me, the only advantage of the language is that it's compiling really quickly, and it has a good enough type system so that, like, I don't write as many bugs as I would in other languages, basically. But yeah, I guess, I don't know. I don't like the language very much, to be honest. But I was previously writing my language in Rust, and I was compiling too slowly, and I really didn't like compiling that slowly. It was taking 1 minute for a smallest change because of the way my language is here, highly recursive and stuff. Because of async abuse. Yeah, it was async abuse and a lot of generic abuse in Rust, which is why my code was compiling very slowly. But like, if you don't use generics, I don't think it's even async. I think it's generics. Bum, 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 bum. High level, and it isn't immutable by default. Well, I mean, no, OCaml is immutable by default. Immutable by default is the good thing. Oh, you mean isn't it immutable? Yeah, it isn't. Yeah, it is. I mean, yeah. Immutable by default, yes, is the good thing. But the mutation, like I do use mutability in OCaml. Mutability in OCaml is very, very dangerous compared to mutability in Rust. It's very, like, as soon as you opt into mutability in OCaml, you're going to have bug immediately. Unless you like really understand what's happening, I guess. Well, you can use it like locally, then it's fine. But no. Computer struggling learning C, beginner of programming. Learning C early on is a great thing. I don't know. It depends on your goals. I think C as a first language is the wrong decision, to be honest. I think that when you're learning programming, you don't want to be thinking about the low-level details, like understanding how computers work. It's not really necessary to do the programming these days. So I think JavaScript or Python is better choices as the first language. Struggle now, less later. It's like learning C is learning like multiple things, like is learning both programming and low-level details of how computers work. And learning JavaScript is just one thing. It's just programming, basically. It's preferential. I don't know, like how can it be preferential? If the person who is learning doesn't know anything yet, how do they know what they prefer? Like the only people who prefer things is the people who have already learned, right? It is easy to transition from C to higher levels, yes, but it is just a lot faster to learn programming if you start from high level. That's my point. If you already know C, then going to another language is easy, sure, yes. But also, if you learn JavaScript first and then go into C, then learning C is going to be easier, I think. But yeah, I guess it like depends on the goal and what are you interested in. But like when I was studying in like the university in school, a lot of like my like classmates, I guess, right? Like I think like a lot of them hated programming because we were being taught C. That's the reason. You know, like sometimes you write code, there is some undefined behavior, like that's not something that you want a beginner to deal with. I don't think so. I don't think undefined behavior, like, it's not even being taught, I think. Really. And then you want to debug your code as a beginner, and your code has undefined behavior. That's fun, right? Um, segmentation fold. Segmentation fold is the best course. Like sometimes your undefined behavior is not necessarily a seg fault. Sometimes it can mean that your program can do some magic, literally. um, what am I doing here? This is substitute row shape, right? So if I have the error, then I just get the error back. That's it. Okay, and now when we're doing this, I'm not doing a value. I'm just instead going to do value into a value await inferred, right? That's also going to look easier. So dot var into this, it's all going to be value await inferred. And this is what type. This should be like type await inferred. So let's say that type await inferred. This should be like type into type shape. That needs to be function type into type variable inference variable await inferred, where error shape is t error. Okay, there we go. What is this? Generic types. Await inferred. Type. Type await inferred type. Okay. Var like that. Value await inferred. Okay, everything is fixed. Type into type await inferred. For syntax, that is a type of type await inferred, I guess. Type that is a value. Okay, this just makes it error resilient, what I'm doing here, so we don't panic. Type await inferred. That's a warning, but it's shown in red for no reason because it's a camel. Type await inferred. Okay, nice. Perform assign, unused recursion. Let's get rid of it. Okay, nice. Now I think I should commit. Okay, this is going to be... This is all value inference, right? Potentially non-inferred values. Everything except for this file. Look at this file. I'm just going to discard the hello world. Which language is OCaml written in? Self-hosted, yeah. I mean, yeah. Most of the languages are self-hosted, right? Except for the dynamically typed ones. The scripting languages. Okay, so now what do I do? Yeah, I want to maybe like do the auto instantiation. Let's do that really quickly. That's the last thing. Or auto instantiation of generics, right? And that's going to be fixing is going to be next time, right? So yeah, what we want is have let's see this. Yeah, so here we go. This is already the example of generics, right? And let's just make this to be understandable. So this is the ID function. Wait. Why can I not hover here? I have syntax highlighting. Why is my hovering not working? Hello? I have type check failure, but that's fine. That's by design there. Last language server. Yeah, I'm having the hovering thing, right? It's not crashing. Mm -hmm. Yeah, I'm going to do the same with my language, right? My language that I'm making here, I'm going to rewrite it in itself. You do that by having first a version of the language that is written in some other language, but then once you have that, you can like, now that you have the binary that was created using another language, now you can use that binary to compile your own language without using the other language anymore. So like the first version of OCaml was not written in OCaml, I guess, because it couldn't exist, right? But eventually they just rewrite the language in itself. Type check failed. Yeah, like, why can I not hover things? Am I stupid right now, or what? What about this? Over here I can hover, but not in the generics file. It's because the type check failed? No, that's not the reason. Guess a number. In guess a number I can hover. That's weird. Anyway, what we want to achieve is that we should be able to call the ID function, which is a function taking like some generic t and returning it back. We should call it without using this. But right now this says that type check failed. We expected a function, but we got a generic function, right? We expected a non-generic function, but we got a generic function, right? So when we see this, when I try to call a function and I already know that it's generic, I should automatically instantiate it. Let's do that real quick. Okay, so we are going to have the thing that is going to be called auto instantiate generics. A generic is an expression, so we're going to have an expression, and it's going to return the expression back. I'm going to have a span here and compiler state too, I guess. So that's going to be a function, span state expression, and then we'll basically do something like this, that match expression type variable into inference variable inferred opt. So we don't wait for it, we see what it is right now, and if we know that it is some type generic, right? And if we know that it's a generic type, then we'll literally just rewrite this expression into a new expression. Into a new expression. Which is expression instantiate. Generic. Right? Expression instantiate generic. This has a generic and the argument. So in this case, the generic is going to be the original expression, and the argument to the generic is going to be the new not inferred thing. Expression placeholder. I want to have this extracted into a thing because I did it in placeholder here already. This over here, this. Let's just say expression placeholder. Folder. Let's go and say expand and state. Expression placeholder. Span state expression is function span state into this. Yeah. Expression placeholder, span state like that. And that's literally all that I need to do, right? And then while I initialize this, I might potentially call the auto instantiation again. But when do we auto instantiate? When I'm calling a function, expression, apply, right? So over here, I auto instantiate the function, right? I just say let f be auto instantiate generics. F span state. That's all. What are the other things when I want to instantiate generics? When I'm having, like, when I'm doing a dot, right? If it's a generic, like, something, you know, if it's a generic module. But I will do that separately later. For now, we just auto instantiate generic functions. But I will do it for other things later. So we do examples, generics. That doesn't work. Okay, nice, beautiful. Wait, what? Continuation already resumed? What? I already resumed a continuation somewhere? Well, now that's a bug. I know why. I know why, I think. Check. We do this in two places. Yeah, that makes sense. That makes sense. How this can happen. But I think I should just do once and for this should be like mutable. That I make sure that it doesn't happen in check. This as data. Can I do that? I just want to say that data dot once inferred is empty list, right? And then apply the functions. Good evening, dealer TW. Mutation already resumed. There's no way. I'm planning to do all of the advent of code. The advent of code this year is going to be shorter than the normal one. It's also only going to be 12 days. Last year I got to day 8, and the only reason I stopped is because my language wasn't good enough. So I think this time I can go further, hopefully. I just need to do like a little bit more improvements before it starts. I should be able to do it all, yeah. We'll see though. Like the only thing that's going to stop me is the language is not going to be implemented. Like I'm going to like some features that is required. My god, this WAG continuation is already resumed. Data. That doesn't fix it. Oh no. I mean, I just have data here. And then we match data inferred with this. I always return data back. But f's is data once inferred. Then I replace them, and then I apply all the functions, right? But it seems like the bug is not here, actually. Continuations. Continuation is already resumed. Is that problem only with that? If I like hello world still works, so it's just the generics that don't? I'm just calling some function once inferred. Pum, 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 pum. Once inferred. Once inferred, I'm trying to... Maybe the stack trace is misleading here. Wait, isn't the only thing that I did was the auto instantiation of generics? Like, what if I do here right now, git stash, and then try to run this again? Okay, I broke this file not in the current commit, but in the other one. Okay, not in the current thing. Git stash pop. I think like auto instantiation of generics should kind of work here. There's something else that's been the problem. Can I maybe like do that? Okay, this kind of works. Expected function. Wait. What do you mean? Expected function. Oh, because ID is not a function, which means that I did not auto instantiate the generics. Did I not? What's the type of ID here? TTT, right? That's correct. It's correct. That works. And that says that it's expected a function, but it's only expected to be a function in the interpreter. Oh, wait, I know why. I know why. I'm stupid. Or am I not stupid? Hold on. Hold on a second. Is it in it? It is. Because I'm saying auto instantiate generics here, right? But this is only figuring out the type here. Yeah. I'm just figuring out the type, but I need to actually rewrite the expression itself. So I need to like potentially overwrite the shape too. Can I say something like this? Let overwrite shape is ref none, maybe. A little weird, but I don't change all the code here. And then over here we'll say shape is overwrite shape option value, and then the default is the shape that I got originally, but maybe I overwrite it, and like in this case, unholy workaround. Yeah, this is bad. This is wrong, kind of a little bit, maybe. But what needs to happen basically is that in the auto instantiate over here, since I overridden the F, right? I have changed it in the shape itself. I don't think I want this to be mutable. No, I think that's wrong. Let's just say that override shape is some apply f arg, you know. Unbound constructor, of course. Expression shape option ref. Okay, and now it works. Okay, so the auto instantiation works, right? Let's see where exactly am I having trouble now. So yeah, this code and this code is the same now, right? Nice. Just for generic functions for now, but I will say that it's done basically. Let's see where I have this bug with the continuation. At which line? Like, do I need to have the compile time error? Oh, maybe like it's yeah, this is over here is totally fine. And that is not fine. Is it because of mutual recursion? Oh, mutual recursion fixes breaks it. Okay. Auto instantiation of generics. Only function calls for now. But it's very easily done in other places. So this bug is because I'm continuing the continuation twice. Boom, 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 boom. Effect continue. Am I actually trying to continue twice in some places potentially? Like there's no way I'm doing that, right? There's no way. I would never do that, right? This is LSP and I'm doing that not in the LSP. Maybe I can see something. Battle error exception continuation already resumed. While I'm compiling this, while I'm initializing this expression, while initializing expression. While initializing this expression. If I don't have this expression, then everything works. And this is where we get the thing. Okay. I would expect that I broke it when I did the inference of values. Potential invert values like this. Maybe let me check out this. And see if it's still broken then. Wait, no, it is still broken then. Okay. Okay, so my generics were broken before. Only print recursive is truly recursive. Do I need to bisect? Let's bisect like the last like this. Something, I don't know. I mean, some of these commits are actually not working, is the issue though. It still is not working. Is it the same issue though? No, this is an exception, which is different. Okay, I mean, let's bisect then. Sure. Git bisect start git bad add git bisect bad add git bisect good this. Okay, what do we have here? That's bad git bisect bad git bisect bad git bisect good. This is the first bad commit. Fix uniting recursive types. Okay, it's because of it's because I have recursive types. Yeah, it's basically when I introduced recursive types. The previous commits, they were still like panicking differently. Okay, yeah. No, I understand. I actually understand. I think the bug is in these files still. Right? Once inferred. Root data with once inferred is F, root data once inferred. Check. Yeah. What? Yes. I need to like and to actually mutate it in place, I'm pretty sure. I mean, in this case, the original one was destroyed. But the data, because of the way I did it, the data could be in other places. Yeah. I think we just do root data, and then over here is to say root data once inferred, root data once inferred. Now that I made it mutable, that's going to be just like that. Can I do git check, git status, git checkout main, Git check out main, and then in main we do that. It kind of makes sense because I still can keep the reference to the old data, so I duplicate the thing. Yeah. We need a language with a borrow checker for this to not happen, right? And with linear types, so that we cannot possibly write code which runs the continuation twice. Let's see, once inferred. Initializing. That is me actually calling the once inferred. Printing. This is uniting the data. Uniting the data. Yeah, but also when I unite the data, I need to make sure that it doesn't exist in the old one anymore, just in case. As data A. As data B. Can I just do here? Instead of this, I'm going to say data A. Once inferred is empty. Data B. Once inferred is empty. Can I do that? Okay. Maybe this is going to fix it. It fixed it. It fixed it. Okay, so this thing actually works, it means. And yeah. So basically we're getting there. All right. I just need to fix the recursive generic types, and that's going to unlock everything, right? Fix running continuation twice bug. Oh, all right, that's good progress for today. Good progress for one day. Let's leave the rest for another day. So you say honest gem is being planned right now.
How do you do /cheer, don't you?
All right, see you guys next time. Bye.